Laser guidance and electro-optical guidance arrived at about the same time, giving a new meaning to the term precision bombing. Our standard iron bombs, ranging from 500 to 3,000 pounds, could now be fitted with electronic eyes. It was a massive job to move this technology from the drawing board to the combat environment of Southeast Asia. But even our overworked ordnance crews, who now had to fit and calibrate guidance kits on each bomb for laser missions, would agree that the results were worth it. The principle is simple enough. An aircraft equipped with a laser illuminator approaches the target and directs the beam on it. The bomb is then delivered, with its detector picking up the reflected laser energy from the target below. It continually corrects its course all the way down, homing in on the target. In the attacking flight, one aircraft can carry the laser designator for all to use. Originally, the F-4 Illuminator aircraft, without bombs of its own, carried a laser designator mounted in the rear cockpit. The latest F-4 version uses a pod-mounted TV camera, four-sided with a laser designator. This allows the Illuminator aircraft to carry its own bomb load, lasering the target for itself and for the follow-on aircraft. One notable limitation is ground visibility. Generally speaking, if the pilot can see the target, he can illuminate it with a laser beam. But laser energy will not penetrate clouds, rain, smoke, or haze. Thus, the always uncertain Vietnam weather often befriended the enemy, negating to some extent the lethal accuracy of laser attacks. In clear weather, the enemy would try to obscure the target with smoke generators, and rain or shine, he used camouflage techniques ingeniously. Nevertheless, laser bomb attacks soon began piling up impressive scores against targets in the extremely high-threat environment of North Vietnam. The results, documented by post-strike reconnaissance photos, speak for themselves. In the later days of our operations, we often sent both conventional and laser-guided ordnance on combined missions. Thus, if target weather worsened en route, we could still stage an effective attack. Well, that Than Hoa Bridge, which had withstood years of conventional weapons attack, was wrecked by 11 aircraft, which did in one day what 600 aircraft could not accomplish in 3 years. And they did the job without receiving a single scratch from the heavy bridge defenses. The Paul Doomer Bridge in Hanoi had been temporarily damaged on several occasions during a 4-year period. But each success took several days to accomplish, and our losses were high. 16 F-4s loaded with laser-guided bombs took out 1,000 feet of this bridge in one day. 130 SAMs were fired at them, but none were hit. 41 MiGs also attacked the force that day, and U.S. fighters downed 10 of them. The Langia Railway Bridge is a very long structure, vital to the North Vietnam-China supply line. On a single day in June 1972, 24 F-4s armed with laser bombs and flying in marginal weather against the heaviest of enemy defenses destroyed 6 of the bridge's 11 spans. A prime example of surgical accuracy is the Lang Chi hydroelectric plant, which provided 1/3 of North Vietnam's power capacity. The turbine building was attacked by 8 aircraft, carrying a total of 15 guided bombs. The crews were under orders to avoid hitting the dam itself, which was adjacent to the plant. 13 bombs were placed inside the turbine building, while the other 2 bombs missed by a mere 100 feet. The dam remained unharmed. Storage areas, airfields, POL facilities, barges, SAM sites, tanks, trucks, and many other targets were destroyed in the linebacker offensive. But listing all these numerous successes would only belabor the point.